All right, we're having a discussion here on hydralazine, also known as epresyline. Also going to discuss a little bit about minoxidil and diazoxide. So hydralazine is a direct vasodilator. Okay, inside of your veins or your blood vessels, you have smooth muscle. So pretend this is your blood vessel, and when the smooth muscle contracts, it tightens down. Okay, so direct vasodilators work to loosen up the muscles in there to dilate your blood vessels. So the way that this one operates, actually the exact mechanism is a little bit unclear as to how hydralazine works. But I know that it must, or the assumption right now is it increases the permeability of the membrane to potassium. Okay, so if you remember the way that there's a certain amount of ions on the outside of a cell, a certain amount of ions on the inside of the cell. Channels open, these ions come through, it changes the membrane potential of the cell and activates things. The cell gets turned on, it's going to open up the sarcoplasmic reticulum and in muscle cells, and it's going to release calcium, and that calcium is going to cause the muscle cell to contract. So if it increases the permeability to potassium, essentially what's going to happen is that potassium is going to have a massive shift, and it's going to cause membrane hyperpolarization. So what I mean by that is so here's 0. Typically when it's in resting membrane potential, it's down here, and then if a bunch of potassium jumps in, it's going to decrease even more. It's going to be hyperpolarized, which means that it requires even more for this cell to become activated. Okay, so it requires even more of a activating factor or whatever to make the cell activated for calcium to release. Now, why is calcium important? Let me explain. Okay, so inside of your cell, inside of your muscle cell, smooth muscle, are these actin filaments and these myosin heads. And this is kind of how it works. So this is an actin filament. You have these little the myosin here, and the myosin has these little heads. And it grabs onto the active sites, and it kind of walks up this. And as it walks up, it tightens the muscle. Okay, so the muscles come together like this. And these little myosin heads are not active unless they have energy from ATP, phosphate. But it doesn't work that simply. There's actually kind of a complicated process here. So what happens, it's not that complicated. What happens is the calcium comes in when it gets activated, whatever, comes out of the sarcoplasmic reticulum, whatever, either or. The calcium binds to a molecule called calmodulin. The calmodulin with the calcium now binds to myosin light chain kinase, or it activates myosin light chain kinase. And then the myosin light chain kinase, you think kinase is a kind because he gives a phosphate. He takes a phosphate from adenosine triphosphate. He takes one of these triphosphate means there's 3 phosphates. Takes off one of these phosphates, makes it adenosine diphosphate, and he gives the phosphate over here to the myosin, which activates it. Now that it's activated, it's going to start tightening down, decreasing, all that stuff. So if this cell has been hyperpolarized, then this here, the sarcoplasmic reticulum, is going to be less likely to open up and let out calcium, which means that it's less likely for that whole process to occur. Apparently also, there is inhibition of the sarcoplasmic release of calcium, and the net effect basically is that there's arterial vasodilation. So when you use this in the case of somebody who has hypertension, generally not first line, but useful in hypertensive emergency because of the rapid onset of action when given with an IV. So if you give hydralazine with an IV, it's really fast, so they usually give it in some kind of hypertensive emergency. Pregnancy has an excellent safety record and refractory hypertension. Okay, so you also can use this in the case of congestive heart failure, CHF, given with nitrates to decrease afterload, decrease preload, and help restore nitroso-redox balance. So another thing that hydralazine is used for is actually as a antioxidant. and it inhibits synthesis of superoxide, and in conjunction with nitrates, which lead to the formation of nitrous oxide or nitric oxide. So one of the points here with this is that hydralazine is, let me make sure I get this right. I said it decreases afterload and preload on the heart, okay? So preload and afterload. Okay, so let's look at it this way. Here's the heart, okay? This is your heart here. So there's an amount of pressure pushing blood into the heart, and that's going to be veins. Veins drain into the heart. There's also an amount of pressure, arteries. There's also an amount of pressure that has to be overcome in order to push the heart out. So in other words, so there's some pressure here. Let's say there's 100 units of pressure, whatever. So this has, in order to get blood from here to here, it has to push harder than 100 units of pressure. Let's say it has to push 120, and then then it would get 20 through, but it has to overcome this. So if over here, if all these arteries squeeze down super tight so that there was 200 units of pressure, well, now this thing, 120 isn't going to cut anymore. It's going to have to push like 220 in order to overcome that. So in the case of hydralazine, what this does is it decreases both preload and afterload. It dilates the veins, which decreases the amount of pressure that's kind of filling the heart. It also dilates the arteries. So it takes this from, let's say, 100 down to like maybe 70 or something. So now the heart doesn't have to work as hard to push blood into the body, overcome that pressure in the aorta. And because it doesn't have to work as hard in order to do that, your heart can take a little bit of a break. Now it only has to push at 90 in order to get blood into the body. And so now you're less likely to suffer from the chest pain, the angina. Anything else on hydralazine? Side effects: you can get a headache, nausea, sweating, and flushing, self-limited lupus-like syndrome in 10% of people. You can get reflex increased heart rate, contractility, renin activity, fluid retention, and possible in response to vasodilation, so often given with a beta blocker, diuretic, or both. Sorry, I went through that kind of quickly. Okay, real quickly, metabolism, you can give it per oral, or PO by your mouth, or IV, intravenously. Hepatic acetylation, so when it goes to the liver, that's how it's broken down. Toxicity, more likely in patients who are slow acetylators. So minoxidil is another one that's discussed in this. This causes vasodilation by opening of the ATP-sensitive potassium channels. So remember, we talked about how what hydralazine does is that it increases the permeability to potassium. So minoxidil, specifically the ATP-sensitive potassium channels. And same thing with minoxidil, it causes hyperpolarization. Apparently also minoxidil, the best known for its side effect is hypertrichosis. So it's typically used to treat male pattern baldness. So I could benefit from that. I'm losing my hair. So minoxidil is used for helping treat early male pattern baldness. Diazoxide, hyperstat, or proglycin. So those are other names for these. By the way, minoxidil, sometimes they call it Lonatin or Rogaine. You probably heard of Rogaine before. That's minoxidil. So diazoxide. This also opens up the potassium channels. I should probably write down, I guess I have them up here. You can hopefully see those. Minoxidil and diazoxide. But yeah, another thing on diazoxide, it opens up the potassium channels on vascular smooth muscle and pancreatic beta cells. So the later effect leading to inhibition of insulin secretion, and it's used for refractory hypoglycemia. Okay, so that's all on those, and yeah, good luck.